All right, hey guys. Didn't have anybody show up to the Zoom meeting. I won't take it personal. Sniff, sniff. But I did still want to share a video with you about the homework that I'm going to put out there today. I did change it a little bit. It's not going to be from page 325 of your book. It's actually going to be on the back of this worksheet, and I've shared this with you, so you don't need to print it off, although you can. But I think probably just sharing this again through Flipgrid probably will be the best way. But what I want to do is start tying this together. We've been finding zeros and rational root theorem and all that, but I want to start tying this in with how do we use this to graph polynomials? How do we use these zeros to actually make up the graph? So we're going to do one example together, and then I've got 4 examples for you to do for homework for this weekend, or on Monday. All right. So if we use this idea of zeros, so it says sketch the graph of this function f of x equals x minus 3 times the quantity x plus 1 times x minus 2. All right. Again, the first thing we would do is look to see if we can find those zeros. And those zeros are going to happen at the values of x that make each of these 0. And again, the good news is we don't have to use the rational root theorem. They've already factored this for us, all right? So I can see one of my zeros is at x equals 3. Another one is at x equals negative 1. And then another 0 is at x equals positive 2. All right? So I know those are zeros of this function, which also tell me it tells me that these are also x-intercepts. All right, so these are points where this line goes through the x-axis. So I'm going to go ahead and plot those things. So there's x equals 3. Here's x equals negative 1. And here's x equals 2. All right, so if we look at this, if we look at, we're looking at what the graph of this thing might look like. We know that it goes through the x-axis at these 3 points, and we also know these are the only 3 points it goes through the x-axis. It never goes through the x-axis because these are the only 3 values of x that'll make this thing 0. All right. So that's kind of a start, but now what does it do when it's not at these points? All right. So what we're going to look at here is, if you look, these 3 points kind of split our graph into kind of 4 different intervals. And I'm going to draw these lines just nice and light. They're not part of my graph. They just kind of help me to explain what I'm talking about here. Okay. So I can see that I've got 4 different intervals, or 4 different regions of this. First of all, I've got all my x's less than negative 1. All right. Now I could write that a couple different ways. I could write x is less than negative 1, or sometimes it's more helpful to put it in interval notation. I'm looking at all my x's from negative infinity up to negative 1. All right. And then we'll worry about these right 2 columns here later. All right. Another interval, all right, is between negative 1 and positive 2. All right. So using inequalities, I could write it this way. X is between negative 1 and 2. All right. X is greater than negative 1 and x is less than 2. Or this interval notation is really kind of handy. Again, that looks like an ordered pair, but really what this is saying is it's the interval from negative 1 up to 2. Okay. The next interval is a little bit smaller. It's just between 2 and 3. So using inequality notation, it'd look like this. Using interval notation, it would look like this. Again, this is not the ordered pair 2, 3. This is the interval, all the x's between 2 and 3. And then the other one is all the x's bigger than negative 3. All right. So using inequality notation, I could write it that way. Using interval notation, I say, well, we're looking from 3 up to infinity. Okay. And so now I want to find an x that is in these intervals. All right. So I want to find an x that is less than negative 1. All right. There's a lot of them out there. I don't care what you choose. Okay. I'm going to choose negative 8. All right. Now so I need to choose a value that's in this interval. All right. So I need an x that's between negative 1 and 2. All right. 0 is always a nice one to pick there. You could have picked positive 1. You could have picked 1.5. You could have picked any x you want between negative 1 and 2. Now I need to pick an x that's between 2 and 3. This one's a little bit trickier, but not really. We're going to have to involve some fractions or some mixed numbers here. All right, so 2.5 could have done 2 3/4 or 2 2/3. A lot of different infinite number of numbers you could pick there, but I'm picking 2.5. And then I need to pick an x that's bigger than 3. All right, again, you can pick whatever you want. I'm going to choose 9. Could have picked 4, 5, 6. Really doesn't matter. Okay, and so now what I'm going to look at is at each of these x's. What is the sign of the function? Okay, and the sign of the function, I'm simply looking, is it positive or is it negative? Okay, I don't care about the value of it right now. I'm just looking at the sign of it. All right, so when I replace x with -8 up here, all right, so if I replace x with -8, -8 minus 3, okay, that's going to be a negative value. When I put -8 in here, -8 plus 1, that's also going to be a negative value. And when I put -8 here, -8 minus 2 is another negative value. And so f of x, or again, you could replace that with y if that makes more sense to you. Okay, so really we're looking at the sign of y here. I'm doing a negative times a negative times a negative, and anytime I do a negative times a negative times a negative, I know my answer is going to be negative. Again, I don't care about the value of it here. I'm just looking at the sign of it. Okay, now what if x is 0? What if I replace x with 0 in each of these situations? Well, 0 minus 3 is -3, so that's a negative. 0 plus 1 is a positive value. And 0 minus 2 is a negative value. So when x is 0, I'm doing a negative times a positive times a negative. When I do that, I get a positive value for y. Now, let me just point something out here, all right? If, at -8, when x is -8, that's somewhere out here. When x is -8, we know we get a negative value for y. Well, if these are the only times this thing goes through the x-axis, if I'm getting a negative value for -8, it means I'm also going to get one for -7, for -6, for -5. For everything out here, this graph has to be down here because it can't go back and forth, because the only way to go back and forth is to go through the x-axis, and I know it doesn't go through the x-axis until it gets right there. So by figuring out that y is negative when I put in -8, that means y is going to be negative for all of these numbers out here. All right, let's go back. Now we're going to put in 2.5. So 2.5 minus 3, that's a negative value. 2.5 plus 1, that's a positive value. And 2.5 minus 2, that's a positive. It's a positive 1/2, but all I care about right now is that it's a positive value. So when x is 2.5, I get a negative times a positive times a positive. That is a negative value. And then finally, when x is 9, all right, or 4, or 5, or whatever you chose here. Let's look at what happens. When x is 9, 9 minus 3, that's 6. That's a positive value. 9 plus 1, that's 10. That's a positive value. And 9 minus 2 is 7. That's a positive value. And so when x is 9, I'm doing a positive times a positive times a positive. I'm getting a positive value here. Okay? And now I can start sketching the graph of this thing. So I know in this first interval, for all the x's less than -1, y is going to be negative. All right? So I know this graph comes down this way. All right, I don't know exactly what it does, but I know it doesn't go up. All right, I know it's not a positive y value. I know it's a negative y value. Now, what happens between -1 and +2? Well, I know y is always positive. So between those, it has to come positive, and then it has to come back down because I know it goes through that point. Now, what happens in this interval, in the third interval, between 2 and 3? I know y is negative. All right, so it dips down here, but I know it has to come back up and hit that point. And then what about the fourth interval? What about when x is greater than 3? Well, when x is greater than 3, for example, when x is 9, I know y is positive, so I know it's above the x-axis, so I know this thing is going like this. And there is just a real quick sketch of what this graph probably resembles. Okay, might not be exact, but we've got some turning points here. We've got what we call a relative maximum before and a relative minimum. We've got the x-intercepts. Okay, and now just for fun, let's just look and see how far off we were here. Okay, so I've been doing some other work on here, so let me clear this off. So I'm actually going to graph this thing. All right, I'm going to graph x minus 3 times x plus 1, making sure I put all these in parentheses, times the quantity x minus 2. All right. And then, just because I've been doing some other stuff, I'm going to hit zoom 6 just to get that standard window. Okay. That's not too shabby. Okay. So, maybe a little bit steeper here, but that's, we get the basic. Maybe a little bit higher here, but we can clean that up later. Right now, I just want you to get the basic shape of this graph. Okay. All right. So that's what you're doing. You're finding the zeros, identifying those intervals, picking an x in those intervals, and just tell me, is y positive or negative? If y is positive, the graph is above the x-axis. If y is negative, it's below the x-axis. All right. So you can go ahead. I've got just these 4 problems on the back. Okay. Just go ahead and graph these, find those intervals. Let me know if you have any questions, but I want you to pay special attention to number 4. We're going to really focus on that next week, and especially what happens here at -3 that's different from everything else because of that exponent here. What happens there? So we might take a look at that, or you can see what you come up with, and then we'll talk about this. All right. So I'll give you today and Monday to get this taken care of, and then we will get together again on Tuesday of next week. All right. Let me know if you have any questions. Have a good weekend. Take care, guys.